Hi, everyone, and thanks for joining me for episode 818 of People Behind the Science. I'm Dr. Marie McNeely, and today we're excited to reshare our conversation with Dr. Mark Saffman. Listeners, Mark's research group focuses on quantum computing. He and his colleagues are trying to build quantum computers that can solve some types of problems that are out of reach for current supercomputers. A quantum computer uses individual atoms and has power that exceeds what you can do with known classical computing approaches. And in our episode, he talks more about his exciting research as well as his life in and outside of the lab. So I hope you're ready for some great stories in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am thrilled to introduce you all to Dr. Mark Saffman. So, Mark, welcome to our show today. How are you?
Very good, thank you.
Wonderful. We are excited to have you here with us and excited to learn more about you and your work. But I want to start off by telling our listeners just a little bit about you. So, listeners, Mark is a professor in the Department of Physics at the University of Wisconsin-Madison. He received his bachelor's degree with honors in applied physics from California Institute of Technology, and he worked as a technical staff member at TRW Defense and Space Systems, and subsequently as an optical engineer at Dantec Electronics Inc. in Denmark, before going back to graduate school to earn his Ph.D. in physics from the University of Colorado at Boulder. Next, Mark worked as a senior scientist at Riso National Laboratory in Denmark, before joining the faculty at the University of Wisconsin-Madison, where he is today. And listeners, Mark has received many honors and awards during his career, including the Vilas Associate Award from the University of Wisconsin-Madison, an Alfred P. Sloan Fellowship, as well as the Research and Creative Work and the William Walter Jr. Awards from the University of Colorado. In addition, Mark has been named a Fellow of the Optical Society of America and a Fellow of the American Physical Society. And Mark has joined us today, listeners, to talk about his experiences in life and science. So, Mark, we want to get to know more about both you and your work. So can you start by telling us what you like to do when you're not doing science?
When I'm not doing science, I'm trying to think when that happens. But
Right.
I have a pretty busy life. Science is more than a full-time occupation. And when I'm not doing science, I'm mainly spending time with my family. I have some young kids at home. I guess one of the things I like to do is, because my work is so busy, get away from everything, get out in the nature, see some different things. I don't have any really strong specific hobbies that I focus on. I think physics is really my hobby.
Excellent. Well, I like to hear that you spend time with your family too, get outside the lab a little bit, enjoy nature. So that's great. So now tell us about your physics next. I'm not very familiar myself with the area of quantum computing. So how do you describe this to someone like me who's not familiar with your work?
I think everyone these days in our modern technology, information-driven society is familiar with computers. Mm-hmm. Most of us have a smartphone in our pocket or bag that's more powerful than the most powerful computer 20 or 30 years ago. And that incredible increase in computing power, which has really changed society in many, many ways, has been driven by progress in nanoscale fabrication, electronics, the ability to put more and more numbers of processing units on small silicon chips. But that progress is approaching an end because people are now building devices that are so small to pack more of them into a small device that each individual device contains just a few electrons or just a few atoms. And when things get that small with small numbers of particles, the way things work gets different, and we get into the realm where we have to describe things with quantum mechanics. Quantum mechanics being the most accurate physical theory we have to describe the way the world works. And in particular, the powers of computers become different. So what we're trying to do in my lab and many other labs around the world is to develop a new kind of computer, a quantum computer, that has the potential to solve some problems that are completely unreachable for current supercomputers and will open up a lot of new applications and possibilities for solving problems. So it's really just a new kind of computer that works with individual atoms and has a power that far exceeds what you could do with known classical approaches.
Very cool. So can you give us an example of one of these problems that's unreachable with other computing methods?
Sure. So one of the challenges that society and technology faces is developing new kinds of materials. For example, we all know about the challenges the world faces with changes in the climate and the situation that's impacted by our burning of fossil fuels and changing the atmosphere around the planet. So one way of generating energy without burning things is, for example, photovoltaics, turning sunlight into electricity. And a lot of engineers and scientists are working very hard to make even more efficient materials. Yet the approaches they have available are really kind of ad hoc. It's not possible to design new, better materials from the ground up. They just have to try different things. And we're not able, with available computers, to solve those design problems because the calculations are too hard. If we had available a quantum computer, we could use it to understand from the bottom up the behavior of specialized designer materials. And that might lead us to new solutions of that problem and also many other problems involving novel materials.
Excellent. Well, Mark, that was a great description, very accessible, and I appreciate that.
Sure.
So we'll chat more about your work as we go through our interview today, but I do want to talk a little bit about motivation. It sounds like you're one of these people who's inherently motivated by your work. You get excited about physics. But do you have a favorite quote or a saying or something that you keep in your mind as you go through your day or as you go through your work?
I have to say I don't have a favorite motivational quote that sticks with me. The only quote that sort of comes back to me is back from my younger days. I used to have this poster up on the wall in my room with a quote by Meher Baba, which said, "Don't worry, be happy."
I like it.
And so try not to sweat the small things and stay focused on where you're trying to get to, and then hopefully things will work out.
Yeah. So do you consider yourself a pretty happy, optimistic kind of person?
Yeah, you have to be. Science is a high-stress activity, and there's always deadlines and always things that are not working out exactly how you want. So learning how to manage that and stay optimistic is an important aspect of being successful and enjoying it.
Absolutely. I 100% agree. And now I'm curious to hear about some of the people who might have motivated or inspired you along your career path. I think this field in physics may not be as well known as some of the others. So are there certain mentors or role models who really turned you onto this area?
Well, I've had a kind of unusual career path. You summarized my career history at the start of this show. And unlike many people, I didn't sort of go on a straight line from school to university to an academic position. I spent a lot of time in industry doing different things. So I've explored some different directions. I guess when I eventually got to graduate school in the early 90s, I had some great classes. One of them that still sticks with me was by a theoretical physicist, atomic physicist, quantum physicist, a person called Peter Zoller, who works in Innsbruck, Austria. He gave a beautiful class in theoretical quantum optics that I took. And at that time, I was just a student. Many years later, it's been such a pleasure to be able to meet him at many meetings. He's a real leader in the field of quantum computing from the theory side. And it's just been rewarding for me to think back to that early class and also to know that I'm able to make a contribution in this area.
Definitely. Well, wonderful to hear about one of these mentors or role models in your own life. And I'm curious, Mark, to hear about where your interest in science began. Do you have a particular memory of when you first started getting interested in science or physics?
I sort of fell into it, but I fell into it because I was always just on the edge of falling into science in the following sense. I'm one of those people who grew up in an academic community. My father was a professor in a different field. Friends that I hung out with when I was growing up, many of those families were academic families. So I sort of grew up in this environment. Nonetheless, when I was younger, I wasn't intending to go into science. I was finishing high school in the 70s, and I was going to go live on a commune and be an organic gardener or something.
Makes sense.
That didn't work out. I kind of fell into science because I was good at it. It was easy for me and it was fun. And I couldn't say I remember when, but as time progressed, my excitement about it just sort of gradually grew.
Gotcha. Do you still dabble in gardening every now and then?
I do have a couple vegetables at home.
Excellent.
But it's a side activity.
Gotcha. So then what happened next once you kind of decided on this path?
Well, I did, and I got my bachelor's degree, and then most people go straight from a bachelor's onto grad school. And I did well. I got my bachelor's with honors, but I couldn't figure out exactly what I wanted to do. So I decided I'd go work for a while. And that was very rewarding. I worked on a number of different projects, got a lot of experience, not just doing science or doing engineering development, but also interacting with people, selling things, presenting myself, presenting what I was doing. And eventually I got tired of that, decided to go to grad school and sort of got more on the academic track. But to me, it's just been valuable working in different areas, both in science and in engineering, and trying some different things, which helped me find what I really like doing, which is what I'm doing now.
Definitely. And I mentioned that a few of your positions previously were in Denmark. What is the connection there?
I spent some time traveling after high school and met a Danish woman, and one thing led to another, and I ended up spending quite a lot of time there.
Excellent. Do you recommend Denmark for our listeners?
It's a beautiful country, and I'm happy to still have scientific collaborations in Denmark. So I get to go there periodically, and it's a small country, but it's a wonderful place, and in many ways, a really great society.
Thank you so much for sharing some of your experiences. And I know many of our listeners out there may be trying to make the decision of what direction they want their careers to go, and maybe deciding right now between academia and industry. So do you have any thoughts that you can share with them about what helped you decide which direction you wanted to go?
Well, I think what's important when you're at a crossroads and you have to make a choice about what to do next, it's important to choose something that really excites you and you're interested in. Don't just follow the path of least resistance and go on to grad school because that's what everyone else is doing, even though you're not really excited about it. If you're not excited about something, don't do that. Find something else to do that excites you, whatever it is.
Gotcha. And then after you got your Ph.D., you actually worked as a senior scientist in a national laboratory. What was that like? Was that more like an industry setting, or was that more like an academic setting?
No, that was an academic setting, and that at a national lab, it was academic. I was also supervising Ph.D. students from the University of Copenhagen while I was there. The lab was just outside Copenhagen. But it was a little bit different than being at a university, in that at the national lab, I had a project that I was requested to work on. And then in addition to that, I could work on other things that I was particularly excited about if I could generate resources to work on them. So that was fine for about 5 years. And then things were getting tighter, and I decided to move back to the States and got a university position.
So what drew you to University of Wisconsin-Madison?
Probably the good weather. Let's see. What drew me? Well,
yeah. Hope you like snow. Yeah.
Academic positions at good universities are hard to come by. So Wisconsin was an attractive place. It's an excellent department. They made me a good offer, and I was happy to come here. To be honest, I didn't know any of the people here before I got here, and I just knew in general it was a good university and a good department. But what drew me to a university leaving the national lab was the opportunity for academic freedom to do research in whatever direction I found most interesting, as long as I could generate the resources for experiments. And I also look forward to spending a bit more time doing teaching. I do enjoy teaching, and that's also been a rewarding part of being on the faculty.
Fantastic. Now, do you think some of the experiences you had in industry have been helpful for your academic experience now?
Definitely, because I run a big lab and we're working on these very difficult quantum computing experiments, and that involves keeping track of a lot of moving parts. There's a lot of people involved, there's personalities involved, there's equipment involved, administration, and the experience you get running a development project in industry turns out to be very valuable also in an academic research setting. In fact, what I do today, some days it reminds me of what I used to do in industry many years ago, developing a product, and that I'm managing a team of people trying to reach a certain goal. So there's a lot of shared skills and experiences that go into those things.
Excellent. Well, thank you for sharing more about your career path. And we mentioned you are now there at the University of Wisconsin-Madison. So is there a project in your current portfolio that you are just so excited to be working on that you want to tell us more about?
Well, it's really the quantum computing. I have a couple different experiments going on. They're all related to trying to answer the question, can we build a useful quantum computing device using individual atoms that we trap with laser beams and control with laser beams? There's a lot of work going on in quantum computing, a lot of research. There's been a huge amount of progress in the last decade. It's gotten to the point where also companies are investing a lot of money and doing their own development in-house now. But we still have not reached the point where quantum computers do anything useful that anyone besides a physicist cares about. Mm-hmm. So I'm really excited about, can we answer that question? Can we build a powerful enough quantum computing machine that will actually do something useful? And I hope we get there at least before the end of my career.
Absolutely. Now, you mentioned that you use specific atoms to do your work. How do you choose which atoms are ideal for these purposes?
Well, there's the periodic table of elements. That gives a lot of possibilities. Some of them are better suited for quantum computing research than others, but we actually work with a couple different types. We work with some simpler atoms, rubidium and cesium. These are atoms that are also used for atomic clocks for timekeeping. And we also work with some very complicated atoms. A species called holmium, which is one of the rare earths, which has an extremely complicated internal structure. And that makes some things harder, but we're hoping to take advantage of that complexity to actually let us do some things that we could not do with the simpler atoms. So we use a couple different types, just motivated by their properties and what we're trying to do with them.
Gotcha. So what are you finding now is one of the biggest challenges in your field, or one of the biggest roadblocks that's keeping you from making these devices?
Really, the big challenge just right now is keeping everything stable and working well. We really understand the physics of what we're trying to do very well, we believe. And we're sort of in the midst of somewhat of an engineering challenge in that we use a lot of very specialized lasers for these experiments. There's a lot of vacuum equipment. There's a lot of optics that has to be very highly stabilized and precisely aligned. And it's sort of straining the limits of what becomes feasible in a university lab with graduate students and postdocs. So it's a very complicated experiment, and we're just working very hard to make it work as well as possible. That's kind of where we are right now.
Excellent. Well, great to hear more about the current work going on in your own laboratory. And I think thus far we've talked about a lot of the wonderful and exciting aspects of your career. We haven't yet touched on some of the challenges, Mark, and I know the world is fraught with challenges and science is no exception. So I do love chatting about the problems, the failures, the difficult times that people have in science, because I think it really helps our listeners out there who might be going through some of these same challenges themselves. So do you have a story of yours that you can share about a failure or challenge?
Science is challenging, and experimental science has its own set of challenges. Science is always challenging in that we're trying to answer questions that we don't know the answer to, or even if an answer exists sometimes. So you have to get used to the feeling of not knowing what you're doing all the time. Once you understand something completely and work it out, then you move on to a new problem. So the life of being a scientist is the life of being always at least partially befuddled and wondering where to find the answer. So one has to get used to that, and that can be challenging just from a personal peace of mind point of view. The actual practice of doing science, particularly doing these experiments that we do, you need a lot of money to do these experiments. You got to buy various pieces of research equipment. They're expensive. So you spend a lot of time writing proposals to get research funding. Sometimes you get it, sometimes you don't. That can be frustrating. So that's a challenge, just keeping the whole operation going, getting the money you need, paying salaries for research colleagues, and so on.
Absolutely. And I love that you reference this perpetual sense of befuddlement that scientists have. I think you're absolutely right there. And this frustration with getting grant funding, I think you're absolutely not alone in this challenge that people are facing. And I think it's becoming more and more difficult. So do you have a recent example of one of these challenges that you can tell us about in a little bit more detail?
Well, I have to be honest, I work in an area, this quantum computing area, that's enjoying a lot of funding these days. So I think there's other scientists and other physicists who could be having a more difficult time than I am. There's a lot of resources going into quantum computing, But we also need a lot of resources to perform these very complex and expensive experiments. I think when one comes up against a dead end or one put a lot of effort into getting funding to do something and it didn't materialize, the thing to do is to think about, well, can I go in some other direction? If I think back to my first couple of years at the university, when I first got here, I had some ideas about which research direction I wanted to go in when I started. And I had a hard time getting support for that direction. Mm-hmm. And then I ended up moving over to this quantum computing area, which has been very successful for me. And it was a growing area. So when things don't work out, you should keep trying to a certain extent, but one also has to realize that it can be necessary to change direction and try and look somewhere else to find something interesting to do. So I guess that's my words of wisdom, if they were.
Yeah, absolutely. I like that. Kind of be open-minded about the opportunities and not sort of stuck in one direction that you think you're going to go. So thank you so much for sharing how you work through one of these challenges, but we don't just want to talk about the tough times, Mark. Can you tell us next about one of your exciting successes in science, whether it was big or small?
I think the most exciting time for us is when we did our first experiment with these atomic quantum bits, what we call qubits, about 6-7 years ago, where we were the first research group to be able to create entanglement of a couple of these bits. Entanglement is, I don't want to get into the technicalities of that for this show, but it's one of the building blocks that one needs to put together a quantum computer that is going to be more powerful than a classical computer. It's creating these very strong correlations between atoms, and we do that by trapping a couple atoms and shining laser beams at them and getting them to talk to each other, to interact in a way that makes them very strongly correlated, that is entangled. We started working on this in about 2002, and in 2010, we were able to demonstrate this for the first time. And that was a big result for us. And that was definitely a lot of fun to get that big result.
Absolutely. So for this process of entanglement, is this something you can see immediately as it's happening, or is it kind of days or weeks later after you process all the data?
Not immediately, but not days and weeks either.
Okay.
To actually get the data to demonstrate the entanglement, that's a few hours of data taking in the experiments we do. Then you've got to analyze it carefully and make sure it really is entangled and you didn't make a mistake somewhere. So within a day or so, you're confident that you got it.
Very cool. So that's relatively immediate gratification, I think, on the scientific continuum, which is great.
That's right.
So can you tell us what was going through your mind when you first saw these results that it was working?
Probably relief, because we've been working on it for such a long time. I think when I started, I thought, well, that looks feasible and we can probably put something together to do this in 2 or 3 years. And it took close to a decade. And that's often the case in science and, of course, many other things, that whatever careful plans you make, reality can throw a wrench in the works and things might take 2 or 3 times longer than you had planned for. So it was just a relief to see it happen.
Yeah, and to have it be a decade in the making, was there ever a moment where you thought of moving away from this area or changing directions again if it wasn't working?
In this quantum computing research, no. Since we started, I've been optimistic that we're going to be able to do some great things. And we have a lot of challenges today trying to go to the next level beyond what we did 6-7 years ago. But I'm still very optimistic that we're going to get there. So we're going to keep at this one.
I like it. I like the optimism, Mark. So thank you so much for sharing one of your fantastic successes in science. And we chatted a little bit about your life outside of science at the beginning, and I think it can be hard for scientists to make time for themselves, to have a life, to do things like read for fun, get out of the house a little bit. But I love getting book recommendations from everyone we have on our program. So, Mark, do you have a book that you want to recommend to me and our listeners today?
I probably don't read as many books outside of physics as I would like to, but I'll mention one that I did enjoy quite a bit that I read a year or so ago. It's sort of a physics book. It's a biography of a physicist. This was a book about Paul Dirac, who was one of the inventors of quantum mechanics. And he was English and spent most of his career in Cambridge, England. And I was born in Cambridge, spent only a couple of years there, but started life there. So it was a fun book. He's a famous physicist, but also a somewhat quirky individual. So I found that book a lot of fun.
It sounds awesome. We'll put that on our website for our listeners to find there. And do you have a favorite physics book you want to recommend as well that's more pure physics?
I have many favorite physics books. If I just look what's on top of my desk right now, I'm teaching atomic physics this term. And there's a lot of books on atomic physics, but I have a great book right here by Hans Bethe and Edwin Salpeter called Quantum Mechanics of 1 and 2 Electron Atoms. It's maybe a kind of a dry book, but it's got everything you could possibly want to know about the hydrogen atom, and I recommend that one.
Excellent. Well, listeners, we'll add these to our reading list if we're looking to dive more into the world of physics. And we've chatted about some different aspects of your career. And I think one thing that keeps coming up, Mark, is some of the opportunities that you've had to travel to different places. You mentioned being born in Cambridge, doing some of your training here in the US, working in Denmark. I think there are so many opportunities for scientists to go to other places, to meet people from these places and to work with them there. So do you have a favorite place that your science has taken you?
You're absolutely right. As a scientist, one of the benefits is the opportunity to travel. And I travel a fair amount, going to give talks places, going to conferences, different places all over the world. I would say that when I think back on all the many meetings I've been to, it's not so much the place, but the people you get a chance to spend time with and the interactions you have. And those are really the strongest memories. But I have been to some great places. One I'll mention in particular was a workshop I was at many years ago now on the island of Crete in Greece. And it was at a hotel complex on the northern side of the island, right by the beach. You could get breakfast, you could go swimming, go to talks, discuss science with the colleagues, go for an afternoon swim. So it was both good science and also a lot of fun to be there.
Excellent. So if our listeners are traveling soon to Crete, what is the one thing that they have to see when they're there?
Well, there's this, I forget the name of it, but there's an old excavated ancient Greek temple that there's, of course, many of those in Greece, but there's one of those on the island also.
Very cool. Well, thanks so much for sharing one of these travel experiences. And we've sort of hinted that the people in science are really part of what makes the career great. And one of the wonderful things about traveling is to meet these people and get to work with them. And I think there's some stereotypes out there, Mark, about what scientists are like. And we try and break those on our program because I think there are so many different types of people in science. People are funny. People are fun. Science is more social than I think a lot of people realize. So do you have a memory of your own or maybe a quirky tradition that you experienced that you think really showcases this human side of science?
You're absolutely right. I mean, science is done with people, and what's really makes science worth doing is not just the scientific advances, but the interactions with colleagues, with students, with competitors, and the back and forth you have with different people at different levels. Quirky traditions? No, we're a pretty straight up lab. I can't really name any from here. But certainly the personal contacts, these people are colleagues and they're also friends. And it's kind of a funny relationship in the sense that there are certain people that you're very friendly with, but you just see them for a day or two every year or two. So you see them very infrequently. And then it's kind of fun how you can be in the same room as someone and you haven't seen them for a couple of years and you can just immediately start talking about your science or your shared interests as though you hadn't missed a day.
You pick right back where you left off. Yeah.
Yeah, that's kind of special.
That's awesome. So you mentioned your lab is pretty traditional, we'll say. You don't have a lot of quirks. Do you do any sort of lab gatherings or events or anything outside the lab with these people?
Every now and then I invite them over for a barbecue. I have to admit I'm a little behind if any of my students listen in.
Yeah.
I haven't done it for a while, but I have done that on occasion. And we try and go for a group lunch with everyone at least once a week. In fact, when this podcast is over, a little bit after, we'll be heading out to lunch today. Here at the University of Wisconsin, the university is right on a lake, and we have a wonderful terrace where you can eat lunch and look at the lake and watch the waves go by. And so when the weather's good, as it is now, we try and do that every week.
Now, do you talk about science at group lunch, or is this strictly no science?
Anything's open. It could be science. It could be other stuff. It could be politics, whatever. Anything goes.
Gotcha. I like it. Well, thank you so much for telling us more about your lab group and some of the fun traditions there. I think that's a great idea, getting everyone together at least once a week to get out there, get outside the lab, enjoy some beautiful scenery on the lake there. That's fantastic. So now we've chatted about some of the big questions that you are tackling with your research today. But I'm curious, if you had all the resources you could dream of, Mark, if you had no barriers, all the staff and funding and technology and whatever you might need, is there one research question that you would want to tackle first?
Well, I will tell you the research question I am tackling is what I'm most excited about. So I'm a happy camper in that I'm working on the thing that I'm most curious about, which is whether or not you really can build this big quantum computer. But I do also look at other parts of science. And I think some of the most exciting stuff going on is just trying to figure out what the universe is made of. So there's a lot of research now going on trying to understand dark matter, dark energy, the composition of the universe. It's not an area I work in at all, but I'm fascinated by that. And I look forward to hearing when my colleagues who are working on those questions gain deeper understanding. So yeah, I think that's really exciting.
Definitely. Do you think those two fields will ever collide, the quantum computing with any sort of new discovery on what the universe is made of?
There are certain connections. One of the mysterious aspects of the universe is black holes. We think we understand what black holes are, but there's paradoxes related to black holes and the way they absorb information without sending it back out. And that turns out to be not unrelated to questions that come up in building quantum computers. So there's mathematical, theoretical connections between quantum computing that I work on from an experimental perspective and understanding the physics of black holes and these strange objects in the universe. So that sometimes happens in science, that connections are formed between two areas that you thought had nothing to do with each other. And then you find there's actually a close relation, and studying one can teach you something about the other or vice versa. Right now, that's kind of hand-waving and fuzzy, but we'll see as science develops if those two areas can get a stronger connection.
Absolutely. Well, Mark, you brought up some interesting things for me and our listeners to ponder as we go through our day here. And we've chatted about some different aspects of your career. And I think it's really helpful to get advice at different points along your career. And I know our listeners out there are always looking for advice to help them along their own scientific journeys. So is there one piece of advice that you received at some point that really helped you that you want to pass on to them today?
Let me mention one piece of advice I received that still sticks with me, and then I'll give my own little bit of advice.
Yeah.
Something I remember just from early on when I was working on an experiment is it's easy to get stuck sometimes and something's not working and you really think it should work and you just keep doing the same thing and you get in a rut. So just remember sometimes the notion that, well, if something's not working, you've got to change something. You got to do something different. And I mean, it sounds silly. It sounds so trivial, right. But it's surprising sometimes how much one can get stuck that way.
Well, I think part of the challenge is you don't know what went wrong, so you keep doing it, trying to figure out what.
Well, that's right. And then should I try something different or should I try and fix what I have? That's one of the challenges that one faces doing science in a laboratory. So that's one thing. Don't just keep doing the same thing. And otherwise, I would just repeat something I think I already said earlier in the show. Find something you're excited about. Don't just do something because everyone else is doing it or you think that's supposed to be the right thing to do. If it doesn't make sense to you and doesn't excite you, find something else, whatever it is.
I like it. Wonderful advice to leave our listeners with today. Mark, is there any other last piece of advice you want to give them or a last note of inspiration you want to leave them with?
I would just say that working in science, whatever field it specifically happens to be, is a wonderful career. You work very hard. It can be all-consuming. But it's a great career and job because every day is different. You don't end up doing the same thing from one day to the next. And so it keeps you fresh and it's a lot of fun and extremely rewarding. So I recommend it to anybody who's interested.
Excellent. Well, thanks so much, Mark. Can you tell our listeners if they want to learn more about you and your work, where should they go?
You could check out my website or send me an email if you have any specific things you wanted to ask about. Instead of giving you my email address, I'll just tell you my last name is not very common at all. If you Google Mark Saffman, you'll find me right away.
I can confirm, listeners, he's very findable, for better or worse, right?
That's right.
Well, Mark, thanks so much for joining us on the program today. Listeners, definitely get in touch if you have any questions and learn more about the amazing work Mark is doing. And it has been a pleasure, Mark, to learn more about you and your story.
Thank you, Marie. My pleasure indeed.
Well, great to have you here today. And listeners, great to have you here as well. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.